A comparison between thermal overload relay and magnetic overload relay. There have been numerous inventions of electrical machines and devices for the ease of human beings, but it is necessary to be ensured to take precautionary measures for the routine operations of these machines. A lot of protective devices are available in the market according to the customer's requirement, i.e. overload relay, circuit breaker, isolator, etc. All these devices act against a fault and play a significant role in the safe operations of the whole electrical system. Currently, our main focus of the study is overload relay, which is widely used with motors to ensure prolonged and secure working by protecting them from any kind of potential risks or faults. There are two major types of overload relays: thermal overload relays and magnetic overload relays. In this article, we will take a look at the comparison of both relays in terms of their different aspects. Working principles. A thermal overload relay is an electronic element, which is generally used in phase failure shielding, overcurrent protection, and protection of AC motors, and other electrical devices and circuits from overheating. During the overload condition, this relay switches off the faulty circuit to protect overheated circuit as soon as the temperature rises above the threshold value. As shown in Figure 1, the bimetallic strip bends on one side to activate a trip mechanism when an overload current causes the heat in a circuit. Nurwati, Argianzia, Dofir, Hasana, Mayani, and Markovich, 2020, September. The magnetic overload relay is a device that changes electrical energy into magnetic strength to deactivate a circuit during an overload situation. This type of relay operates by sensing the intensity of the magnetic field that is created by the flow of overcurrent towards a machine. It is used in acute overload conditions, which is caused by internal fault or short circuit in an equipment. The magnetic flux is directly proportional to the magnitude of current. Due to the presence of current, the magnetic flux inside the coil forces the core to move upside. The core trips the set of links on the peak of the relay as soon as it rises sufficiently. Figure 2, Human, 1953. Compositions. The composition of a thermal overload relay includes a heating component or element, a bimetallic strip, and an arrangement of transmission and adjustment systems. The bimetallic strip is the most crucial part of this relay. It is manufactured through the mechanical rolling of two metal strips of different linear extension coefficients. The heating element is in the shape of a filament. It is composed of nickel-chromium alloy, copper-nickel alloy, or chromium-aluminium alloy. Due to its simple design, compact size, and low cost, a thermal relay has vast utilization in the production fields. Nurwati, Argianzia, Dofir, Hasana, Mayani, and Markovich, 2020, September. The structure of a magnetic overload relay consists of a movable magnetic core within a coil that possesses the current. Apart from this, there are an armature, a spring, and movable and static connections in this relay. It has the ability to manage high power to control the load. Kuhn, 1937. Classifications. There are three different types of thermal overload relays, i.e. single-phase, two-phase, and three-phase. Figure 3. Depending upon the rated current of the heating element, each of the above-said types has different models, properties, and specifications. However, the three-phase type of this relay is mostly used with three-phase AC motors to protect them in overload conditions. Upon further classification, three-phase thermal overload relays are available with phase protection and without phase protection properties. These relays are also available in automatic type to cater the modern age requirement. Magnetic overload relays have two specific types, electronic and dashpot. The electronic overload relays consist of a current transformer to detect the motor overload current. These relays are usually programmable, having the ability to be set for full load current, different levels and percentages of voltage, and other particular factors. These relays have also a three-phase configuration. On the other hand, a dashpot overload relay consists of a dashpot oil-filled container, piston, shaft and a coil which is connected in series with motor. The causes of overload tripping. The tripping of thermal overload relay happens due to following reasons. Overload current. Too low threshold value. Short circuit fault in a motor circuit. Poor quality of the relay. The magnetic overload relay has almost the same tripping causes as mentioned above. Advantages and disadvantages. There are some following noticeable advantages and disadvantages of both types of overload relays. Advantages of thermal overload relay. More convenient with efficient operating principle which results in high accuracy and protection to connected load. Suitable to use with single and three-phase electrical motors to protect from internal phase losses. Cost-effective and easy to install by using rail adapters. Available with internal trip level selection and internal testing switch for troubleshooting. Available in manual and automatic reset functions for convenient operations. Salient features of modifiable current range and temperature compensation for precise functioning. Not suitable for short-circuit protection. Needs to use with other protection devices instead of direct disconnecting live circuits. Slow in operation. Not suitable to perform against high-resistance circuits but against low-resistance circuits. Unable to withstand vibrations and electrical shocks. Required some time to cool down after overheat tripping. Prominent for speedy operation and reset. Can be used for both AC and DC devices. Simple, compact, sturdy, and reliable. Adjustable operating time and reset according to current range. Instrument transformers, CTs and PTs, are required to operate these relays. Lack of directional function. Regular maintenance and testing is required. Functioning effects due to aging and environmental pollution. Limited operations pace due to mechanical inertia of parts. Disadvantages of thermal overload relay. Advantages of magnetic overload relay. Disadvantages of magnetic overload relay. Conclusion. The above study concludes that the overload relay is one of the crucial parts of a circuit, whether it is in the form of a thermal overload relay or magnetic overload relay, to provide protection against overload current and any other failures. Both relays have their own significance based on the working principle and properties according to the requirement. It is the most important to keep technical requirements in consideration for the right selection of overload relay to avoid any kind of mishap. References. Middle.Human, G. W. 1953. Overload relays and circuit breakers for protecting motorized appliances in their branch circuits. Electrical Engineering, 7212, 1056-1060. Middle.Nirwati, T. Argianzia, B. Dofir, M. Hasana, R. N. Mayani, W. M. H. and Markovich, M. 2020, September. Simulation of thermal distribution on a ferrofluid bimetallic overload relay. In 2020 Forte International Conference on Electrical Engineering, Forte IC, pages 91-95. IEEE. Middle.Kuhn, C. W. 1937. AC Motor Protection. Electrical Engineering, 56.5, 589-593. https://shop.schneiderelectric.co.in/blog/post/what is a thermal overload relay.html #: text equals advantages %20 of %20 thermal %20 overload %20 relays and text equals %2d %20 thermal %20 overload %20 relays %20 or %20 primarily, protection %20 from %20 internal %20 phase %20 losses. Name: Auto Inc. Address, 23555 Golden Springs Dr. I, Diamond Bar, California 91765. Use a contact mail, sales@auto.com. Contact number, 1-800-585-1519.